Hi folks, Dr. White here, just going over some stoichiometry problems from the review problem set. These are a mixture of stoichiometry problems. You're going to see problems with moles, problems with grams, problems with limiting reagents, and then probably a percent yield problem. Okay, so here's number one. Let's go through it. Tin chloride, SnCl2. Okay, reacts with oxygen gas to produce tin oxide and chlorine dioxide. Remember, first step, always want the balanced chemical equation. Let's go ahead and do that. SnCl2 reacts with oxygen gas. Remember, oxygen gas is O2, right? Oxygen is one of the diatomics. Produce tin oxide, tin 2 oxide to be specific. Let's just make sure that the charges balance out there. Okay, 1 to 1, that's great. And then chlorine dioxide. So 1 chlorine, 2 oxide. Let's make sure we're balanced here. Looks like we got 2 chlorines on the left, 1 on the right. Let's put a 2 there. Now we got 4 oxygens, 5 oxygens. We got 2 oxygens there. That's not going to work. We're going to have to turn the oxygens into an even number. The easiest way to do that is to put a 2 right here in there. So now we've got to put a 2 here, which means that the chlorine, we're going to have to cross out this 2, and this is going to turn into a 4. Now we've got 8 oxygens, 2 oxygens, that's 10 oxygens total, a little 5 here. There is our balanced chemical equation. Okay. Now, second step to these problems, you always want to set up the BCA chart, right? That's the before, change, and after. It just helps us keep track of how many reagents we have and how many products we have before, during, and after the reaction. So if we have 0.75 moles of oxygen, let's go ahead and write that in here. And that was consumed using this chemical equation. What is the mass of tin 2 oxide? So we're trying to figure out how much of this is after it. Okay, so let's say this is going to be, I'm going to assume this is going to be excess. Okay, we've got more than we need, so let's not even worry about that. Okay, so if we got 0.75 moles and we react all of that, we're going to get rid of 0.75 moles. And in the end, we're going to have 0 moles. Well, here's the question. How many moles of, I'm going to start out with 0. How many moles of tin 2 oxide am I going to make? Well, you have to use the ratio in the chemical equation. For every 5 moles of oxygen, I'm going to make 2 moles of tin 2 oxide. So let's go ahead and calculate that out. Okay? So if my ratio, I'm going to put this down here, 5 oxygens and 2 SNOs. If I start off with 0.75 oxygens, moles of oxygen, how many SNO am I going to make? Okay, so X is going to equal 0.3 if my math skills are good. I'm going to make 0.30 moles of SNO. Now the question is, what mass of tin 2 oxide am I going to make? So in the end, I'm going to have 0.30 moles, but what's the mass of this? How do I find the mass? How many grams of this is there? Well, you have to remember that when you have the moles, you can always find the grams when you multiply by the molar mass. Okay? So the molar mass of tin 2 oxide, let's go ahead and figure that out. So if 1 mole of tin 2 oxide is 144.7 grams, if I have 0.30 moles, how many grams is that going to be? Well, let's go ahead and figure that out. So it's going to be 0.30 times 144.7. We're talking 43.4 grams of SNO. That will be our answer for number 1. Okay, stoichiometry review problem number 2. Magnesium sulfate, MgSO4. Let's go ahead and start this out. Decomposes when heated to produce magnesium sulfide and oxygen gas. Let's get our balanced equation. Magnesium sulfide is heated. It decomposes when it's heated. Usually the symbol for heat is a triangle. You put it over the arrow to produce magnesium sulfide and oxygen gas. Okay, that's O2, remember. Let's go ahead and balance this. Okay, we've got 1 Mg on both sides, 1 S on both sides. We just got to put a 2 here, and we are balanced. Next step, BCA chart. Okay, 6.32 grams of MgSO4 were heated in the tube, and they reacted. What mass of oxygen gas is left? Okay, so we're looking for the oxygen gas. That's our X, and they give us 6.32 grams of MgSO4. Okay, now remember, before we can go anywhere with our BCA chart, we've got to turn these grams into moles. Let's go ahead and do that. If 1 mole of MgSO4 is 120.3 grams, if I have 6.32 grams, how many moles is that going to be? We're looking at 0.0525 moles of MgSO4. Okay, we can put that in our BCA table. 0.0525 moles. Okay, then I want to figure out how much oxygen gas is produced. Well, there's 0 before the reaction. If this totally reacts, we're going to get rid of all of it, right? In the end, we're going to have none of this left. Now, how many moles of oxygen are we going to create when we do this reaction? Well, the ratio is 1, right? If there's no number here, you just consider it a 1. 1 magnesium sulfate generates 2 oxygen. So if I have 0.025 moles of magnesium sulfide that reacted, I'm going to make twice that of oxygen. So if I go ahead and solve this, we're going to produce 0.105 moles of oxygen. The question is, what's the mass of oxygen gas that's going to be released? Let's go ahead and find that. We need to find grams. How many grams is that? Well, if we go through and let's just do another ratio here. If 1 mole of O2 is equal to 32 grams, right? I get that from the periodic table. If I have 0.105 moles, how many grams is that going to be? Well, let's do a little magic here. Erase the equal signs. Let's put a line in here, make them ratios, equals that. X is going to be 0.105 times 32. We're talking 3.36 grams of O2. Okay, stoichiometry review problem number 3. Okay, mass of CO is used up in the reaction with excess oxygen. Looks like we've got the chemical equation right here. Let's just go ahead and write that down in the center. Okay, looks like we're balanced. Let's just think about what we got before our change and our after. Okay, CO is used up in the reaction with an excess of oxygen gas. Excess means that you've got more than enough oxygen, so that's not going to really determine how many products you can make. What you care about here is the 24.7 grams of carbon dioxide. Well, let's turn that into moles, right? We've got to, if we're going to put anything into our BCA chart, we need moles. Okay, so if 1 mole of carbon dioxide equals, from the periodic table, 44 grams, If I have 24.7 grams, how many moles is that going to be? Well, if you get rid of, if we just put some lines in here, put an equal sign there, get rid of these equal signs, then you get a ratio, right? You can do a little cross multiplication. Okay, you'll find that we get 0.625 moles of CO2 in 24.7 grams. So that's what we put into our BCA table. We're going to fully react that, right? We're going to have 0 left over. Start off with 0 of CO2. How many are we going to make? Well, the ratio in the reaction is 2 to 2. That's the same as 1 to 1. So we're going to make 0.625 moles of CO2 if we react to 6.25 moles of CO. In the end, we've got 0.625 moles. Okay. Now, they're asking about what is the mass of CO that was used up. Okay, so we're talking about the CO here. Okay. If we used up 0.625 moles of CO, what's the mass there? Well, let's go ahead and see if we can use our periodic table to figure that out. If 1 mole of CO is equal to 16 plus 12, that is 28. 28 grams. If I have 0.625 moles, that's going to be equal to how many grams? Okay, do a little magic here, turn these into fractions, get rid of these equal signs and put an equal sign there, cross multiply, solve for x, 17.5 grams of CO was used up. Voila. Stoichiometry review problem number 4. Reaction, 32 grams of CH4, excess oxygen gas, produces CO2 and water. This is your typical combustion reaction. We've got to determine the percent yield here. Okay, so CH4 plus oxygen gas, remember that's diatomic, reacts to form CO2 plus water. Okay. We balanced. Looks like we need to put a 2 here and a 2 there. Okay. BCHR. Okay, 32 grams of CH4. We're going to need to turn that into moles. Let's do that real quick. 32 grams of CH4 is equal to X moles. If we know that from the periodic table, 16 grams of CH4 is equal to 1 mole. Well, this should be an easy one to figure out. X is equal to 2. Okay, so we've got 2 moles of CH4. Excess oxygen, let's not worry about that. We're going to react completely our 2 moles of CH, and we're going to get 0 moles at the end. We're asking about CO2 gas here, right? So let's figure out how many moles of CO2 gas we're going to make. Well, the ratio is 1 to 1. So if I react 2 moles, I'm going to start off with 0. If I react 2 moles of CH4, I'm going to make 2 moles of CO2 and 4 moles of water. In the end, I'm going to have 2 moles of CO2 and 4 moles of water. Now, how many grams of CO2 is this? We're going to need to figure out. If we figure out the grams, this is going to be our theoretical yield. Okay, let's go ahead and do that calculation real quick. If 1 mole of CO2 is equal to 44 grams, if I have 2 moles of CO2, how many grams is that going to be? Well, it doesn't take a math major to figure out that X is going to be equal to 88 grams. Right? 2 moles is 88 grams. This is our theoretical yield. Now, but we want to get the percent yield. Remember, percent yield is our actual over the theoretical, right? Because life isn't perfect. We're always going to get less than we thought we were going to get. So let's plug it in. Actual is 75.9 grams. Remember, we have to give that to you in the problem if we want you to figure this out. Theoretical is 88 grams. Multiply that by 100. Quick calculation. We are looking at an 86% yield. Okay, stoichiometry review problem number 5. This is the granddaddy of them all. This is a, looks like they're giving us 2 different reagents. So this is a limiting reagent problem. Let's go through this step by step. If we've got, well, first step is always write out the balanced chemical equation. So we're talking about copper, that's Cu, silver nitrate, silver's Ag, nitrate, look that up in your table for polyatomics, is NO3. Charge on nitrate is -1, silver is +1. Looks like it's a 1-to-1 ratio. We're good there as far as the formula. It reacts to make copper 2 nitrate, Cu2 plus, nitrate is -1. Looks like we're going to need 2 nitrates there, and silver. Okay, silver by itself is just Ag. Let's go ahead and balance that. Looks like we're going to need 2 of these because of the nitrates, and then 2 silvers. Okay, next step, before change after. Okay, now remember, if you're going to put anything into your before change after table, you need moles. Okay, so what they give us is grams, so we're going to need to turn those into moles. I'm going to do this a little bit different way than before. Okay, 0.651 grams of copper. We want to know how many moles that is. We can compare it to its molar mass, which is 63.5 grams per 1 mole. And then we can just solve for x. Okay, x is going to be equal to 0.106. 0.106 moles. Now, how much silver nitrate do we have in moles? Let's go ahead and figure that out. So, we've got 28.4 grams of silver nitrate. The question is, how many moles is that? X number of moles. Well, in 1 mole, what's the mass of silver nitrate? Silver nitrate is 169.9 grams per mole. So if we've got 28.4 grams, we're going to end up with 0.167 moles. So that's what goes into... Now, we've got to figure out what the limiting reagent is. So in the limiting reagent is the reagent that we run out of first. The way I like to find it when I'm doing these types of problems, I always ask myself a question. If I start out with 0.106 moles of copper, how much silver nitrate do I need to completely react with that? If the ratio is 1 coppers per 2 silver nitrate, and I've got 0.106 moles of copper, I'm going to need 0.212 moles of AgNO3. Do I have 0.212 moles? No, I don't. I've only got 0.167. That means that AgNO3 is my limiting reagent. So I'm going to use up all of that. Okay, I'm going to react, because the ratio is 2 to 1. I'm going to react 0.083 moles of copper. There's 0 moles left here. I'm going to have 0.023 moles of copper left over. What is the theoretical mass of silver, though? Well, let's figure that out. If I react 0.167 moles of silver nitrate and I'm going to make 2 moles of silver, I'm actually going to make 0.167 moles of silver product. Now, we want to know the theoretical mass, right? So let's turn that into grams. Now, an easy way to go from moles to grams, you could go ahead and go through and do the ratio if you want, if that works better for you. But there's kind of a shortcut. Just remember, if you want to get from moles to grams, you've got to multiply by the molar mass. The molar mass of silver is 107.9. If I have 0.167 moles, I'm going to make 18.0 grams of silver. This is my theoretical yield. If the actual yield is 14.3 grams, what's the percent yield? Well, it is actual over theoretical times 100%, right? If we work that calculation out, actual, it's what we always give you, 14.3 grams. Theoretical is 18 grams. Multiply that by 100. Our percent yield is going to be 79.4%.